In the last episode, we saw how ROS2 can use services to handle request type messages. We wrote custom server and client nodes in Python to do this. This time, we'll repeat that same exercise, but with C++ instead. Up till now, we focused on describing what ROS is, when you should consider using it, and a few tools to help you debug ROS programs. And then we covered the two main types of communication protocols in ROS, topics and services. We'll finish this section with a demonstration on how to write clients and servers using C++. Let's get started with some code. Let's open up VS Code in our Docker container, but we will go to desktop 2, fire up a terminal. Let's take a look at ROS2 interface list. These are all of the available interfaces. We have both the topic message interfaces listed as messages, and we also have service interfaces listed under services. We won't be using actions in this series, so you can skip those for now, but we will be using this example interfaces, and in there you'll see that it's divided up between MSG, for message, that's for topics, and SRV, that's for services. So we will be using AddTwoInts. If we say ROS2 interface show example interfaces /SRV /AddTwoInts, you can see that interface here. There are two fields for the request, A and B, both are 64-bit integers. There is a .. that divides the request from the response interface, and the response should be a 64-bit value. That field is called sum. We will be using this interface to create an example server and client so you can see how services work from a C++ perspective, similar to what we saw in the previous episode, which was all Python. Let's head back to VS Code. In my CPP package in source, we will create a new file. We will call it minimalserver.cpp. We want to include the rclcpp header file, and we will also include the AddTwoInts header file from example interfaces and the service interfaces in that directory. Just like we saw with Python and our previous examples, we need to subclass from node, and we will call this one minimal server. The signature for our constructor will include a call to the node parent class constructor, where we pass in the name of this node, which we will call minimal server. Then we will create a service object. That's what turns our node into a server. We call the create service function from node, and we pass in the type for the template, example interfaces SRV AddTwoInts. We give it the name of the service, AddInts, and we tell it which callback should be used whenever a request arrives. In this case, we will bind server callback, which we will write soon, and we will also put in two placeholder variables. This will be one for request and one for the response. Let's go ahead and declare our server member variable. It will be a shared pointer to a service object, and this is a template class, so we need to give it that type. In this case, it's going to be the AddTwoInts type we get from our example interfaces. Then we'll write our server callback function. As we saw with the placeholders, we need two parameters here. One is the request, and this should be of type AddTwoInts request and a shared pointer to that request. We also want a response, so we will use AddTwoInts response and a shared pointer to that. To construct the response, it should already have that sum field in there, as we saw with the interface. We will just add A and B from the request, and we just set sum to that value. Note that we have a constant shared pointer here. We can change the values in that object, so whenever this function returns, so whatever is in response gets automatically sent back to the client. Then we will log that request to the console and any other logging you might have enabled. We will get the logger, we will construct the string, and we will write out which A and B we received from the request. Then we will write our main entry point, as we've seen before. This is very common boilerplate you will come across in ROS2. We'll initialize rclcpp. We will create a pointer to our node. In this case, it's the minimal server type. We will spin that node, which just means run it in a process. And if and when that exits, we will call the shutdown function to gracefully clean up everything and then return 0. With that, our node is done, and this little squiggle line here tells me that I forgot my semicolon at the end of my class, like I seem to have a habit of doing. but we need to add our executable to cmakelists.txt. So below your other add executable lines, let's add our new executable target. So we will write add executable minimal server. We will give it the location of the minimal server file that we just wrote. We will ament target dependencies, which says to our target link rclcpp and example interfaces. And we need to add minimal server to our install binaries list. So save cmakelists.txt. Don't forget to save your CPP file. Let's bring up view terminal, and we will call callcon build -- packages -- select my CPP package. With any luck, that should build without error. Click that message to get rid of it. Let's head on over to our run desktop. Don't forget we need to go into our workspace and then call source install setup.bash so that ROS2 knows where to find our custom packages we just built. And then we will call ROS2 run my CPP package minimal server. If it's working, you should see nothing happening here, meaning no errors have occurred. Let's bring up a new terminal. If we call ROS2 service list, you should see the available services. Recall that ROS2 automatically creates services for any running node so that you can work with parameters. This is something we'll explore in a future episode. But we also have this AddTwoInts service that we created in our custom node. We can then call ROS2 service info/AddTwoInts to get information about that service. You can see the type here, and that is that example interfaces SRV AddTwoInts. We can then write ROS2 service call in order to create a dummy client to try calling our service. We need to give it the service name /AddTwoInts, the interface, in this case example interfaces service AddTwoInts, and then we actually create the request. We use the YAML format to do that. So as a string in curly braces, we will say A:, we'll assign it the value 10, and then comma B:, and the value 12. Press enter. That should call your server, and the server should respond with the sum. So if you look in the terminal for the server, you can see the incoming request, and then our dummy client, our call function here, it returned with a response of sum equals 22. So it looks like our server is working. If you bring up a third terminal to bring up the RQT GUI interface, we can go to plugins, introspection, node graph. We only see our server running. The client shut down immediately after calling. We can also go to plugins, services, service caller. This gives us a graphical version of this ROS2 service call tool we just used. We can fill out A to be something like 2. We can fill out B to be 3. I'm just double clicking on expression here by the fields. We can say call. You can see that called our server. So received request A = 2, B = 3, and it returned a response with sum equal to 5. If you'd like to learn more about services in C++, you can head to the official ROS or rclcpp documentation for C++. Scroll down and you can see service client, which we're about to write, and service server. So this is where we did create service. You can click on that and get information about that function. You can also learn about the template class service in those docs. Let's head back to our code. I will close down RQT. Let's Control-C on our server to stop that from running, and let's head back to VS Code. In src, under my CPP package, let's create a new file. I'm going to call this minimalclient.cpp. In here, we will create a client that periodically calls our server. I'm going to zoom in a little bit so you can see what's going on, and I'm going to close down that terminal. Let's include the standard random library. We will also include rclcpp and example interfaces SRV AddTwoInts. We will subclass node as we've been doing, and we will call this class minimal client. In our constructor, we will call the parent class node constructor as well. We will pass in minimal client as the node name. Then we will create a client object using the nodes create client method. We'll give it the type AddTwoInts as part of that template, and we will pass in the service that we want to talk to. In this case, the service is AddTwoInts, which should line up with the service name given in our minimal server. As we saw in the Python example, we generally want to wait for the service to become available before doing anything with the client to try to talk to that server, because it probably means the server isn't running. So we will call this wait for service. That's part of the client object. We'll give it a standard duration, in this case 2 seconds. And as long as the service is not available, we will just loop forever and every 2 seconds print out this waiting for service. We will seed the random number generator, and we will do so using the current time. This is a bit of a hack. It's definitely not cryptographically secure, but it's good enough for our simple test here. We will then create a wall timer just like we did in that minimal publisher example. We will give it 2 seconds this time, so 2000 milliseconds. And we will bind timer callback, which gets called periodically, or every 2 seconds in this case. In the private section, let's go ahead and declare our member variables. In this case, we want our client, sort of like we did for the publisher and subscriber. In this case, we will use the client template class. That's part of rclcpp. We will give it the type AddTwoInts, and we will get a shared pointer from that. So client underscore is a shared pointer to that object. We will also get a pointer to this timer base so that we can have a timer object that's used to periodically call our function. Here is our timer callback that gets called every 2 seconds. Using the standard library makeShared function, we need to give it the type of example interfaces, server, AddTwoInts, and request for that. So now we have a request that we can fill out. We can access the A and B fields within that request. We will use the standard library random function, or rand, and we will modulo with 11. That should give us values between 0 and 10 inclusive for both A and B. Then we will send the request to the server, and we will set a callback. We will use this async send request that's part of the client object. The first parameter is the actual request, and then we will set a binding here using that bind function in the standard library. In there, we'll give it the response callback, which is a function we're about to write, this referring to this particular instance of the class, and we will give it one placeholder because that should be the response that ROS2 gives back to us. Here we will write the callback function that gets called whenever a response comes back from the server. The type here is a little long. It's a shared future that's part of the client namespace. In this case, the client is of type AddTwoInts, so we pass that interface in as part of that template. And a future works very similar to the futures you saw in the Python episode. This is a variable that gets filled out later. We can assume that by the time this function is called, that future is filled out and we can just access the results here. Keep in mind that when we're writing these response callbacks, you should be expecting in your parameters a future, not an actual response. That means we have to call future.get, which we will do right now. So assuming that future has been filled out, we can call future.get, use auto so that our resp variable automatically figures out which type it needs to be. Then we will simply log the result to the console and any other logging. We will get the logger, use the string result, colon, and whatever the integer is. We will cast resp sum as an integer, and that should fill out the rest of that string. Let's not forget to put a semicolon at the end of our class, because that's what C++ wants. And here is our boilerplate for our main entry point. Hopefully you're getting sick of seeing this, but it's good to get the practice in. While you can do other stuff with it, it's often used just to spin up the node and let it run. The only difference here is that for makeShared, we are giving it the type minimal client instead of something else because that's the name of our node class. We will let that run, shut down when it's finished running, or we give it Control-C or some type of interrupt, and then return 0 to let the main process know that everything completed successfully. Let's save that. Let's go to cmakelists.txt, and we'll add another target here for our executable. We'll call addExecutable, give it our target of minimal client, tell it where to find that file, and then we need to call ament target dependencies, give it that target and whatever ROS packages it's depending on, in this case rclcpp and example interfaces. Finally, we need to add it to our list of installed binaries, which will tell CMake where to install all of these, including our new minimal client. Let's save that. We will go to the run terminals over here in this other desktop. In the client one, we need to go to config workspace, and we need to call source install setup.bash, as we've been doing, so that ROS2 knows where to find our custom packages. Then we'll call ROS2 run mycpp package minimal client. No executable found, and that is because even though I added it here, I forgot to actually build. So let's go to View, Terminal, And we will say callcon build -- packages select my CPP package. Hopefully that builds without error. Looks like we had some error. If we scroll up to the top, we can see some of the errors here and try to fix them. All right, let's head on over to minimal client and scroll up to see what's going on. It looks like I forgot to add parentheses for parameters for minimal client. Let's try building again. Looks like it built this time. Let's go back over to our run terminals. I'll press up so we can run it a little more quickly. In a couple of seconds, you should see it saying waiting for service. Now we need to run our server. So I'm going to press up to see ROS2 run my CPP package, minimal server, run that. The client should connect and we start seeing results. And you can see that it sends over random integers between 0 and 10 inclusive, and it sends back the result of that addition. With that, our example server and client are done for C++. Feel free to press Ctrl+C to exit out of your server and client. I hope this has helped you see how to create servers and clients using the built-in ROS service API to communicate between nodes. At this point, we've covered the basic communication schemes in ROS, which means we can dive into some of the finer details so you can get started creating your own programs. Next time, we'll cover custom interfaces so you don't have to continue to rely on the default example interfaces provided by ROS.